Hi everyone, my name is Pane and today I am presenting analysis of self-driving car. In this presentation, I will mainly focus on three areas: how self-driving car work, the major technical challenges they face, and ethical issue involved. I will also compare the two important real-world systems, Waymo drivers and Tesla driving car. Development of self-driving cars. First, let's look brief about how autonomous driving car develop. The technology starts from areas such as of robotic, computer vision, and control system. In 2004, Java challenged no vehicle were able to complete the desert road. Now, in 2005, however, uh, five vehicles successfully complete the challenges. Today, we have different level of autonomous. For example, Tesla FSD supervised in level 2, meaning the human driver is still responsible. Waymo operate at level 4 within a specific operational design domain. How the system works. Now I will explain the basic architecture of self-driving car. The process starts with the sensors such as camera, radar, and lidar. The perception system then identifies the object, lane, and traffic signal. Next is localization, where which determine where the vehicle is. Prediction estimate what other road user might do. Planning then choose a safe and legal path. Finally, the control system convert that decision into steering, braking, and acceleration. An important point is in that an error in one stage can affect the next stage. For example, if the system failed to detect a cyclist during the perception, the prediction and the planning system may also make wrong decisions. That's why the safety supervisor is needed across the whole pipeline. The main technical challenges. One of the biggest challenges is perception. Real roads are unpredictable. Sensors can be affected by rain, fog, darkness, glacier, drought lines. And another challenge is something called a distribution shift. A system may be trained on a common situation, but real road can contain unusual objects or road conditions and that were not present in the training data. Prediction is also a different because humans do not always behave predictably. For example, predator may either wait on the footpath or suddenly cross the road. Therefore, the systems will consider the multiple possible future instead of assuming only one outcomes. Other safety challenges. There are also several other important technical challenges. First is localization. GPS or GNS can become unreliable in tunnel or areas surrounded by a tall building, and map can be outdated. And secondly, in latency. In autonomous driver, being a coverage is not enough. The system can need to be respond quickly. Third is verification. Developer need simulation, real-world testing, scenario replay, and fault injection to be tested on usual situation. Finally, cybersecurity is also important because the attacker can attack affect the system control or physical vehicle. So autonomous or driver require much more than just an accurate AI model. Waymo. Now let's look at a Waymo. Waymo use a level 4 approach. This means the vehicle can operate without a human driver, but only within a defined operational design domain. Waymo use multiple types of sensor including camera, radar, and together with GNS, IMU and on-board computing. In software, combines sensor information with localization, prediction and planning. The main advantage of this approach is that Waymo can limit the environment where the system operates. This make the problem one manageable and allow the company to validate the system within the specific location. However, This approach also have a disadvantage, including high cost, mapping requirement, and slower geographical expansion. Now let's talk about Tesla. In comparison, Tesla take a different approach. Tesla full driving car supervised in level 2, so the human driver remains responsible for the vehicle. Tesla system is mainly camera based and uses a communal camera for driving monitoring. One major advantage is scalable. Tesla has a large number of the consumer vehicle which provide a large amount of the driver data and allow software update to deliver over the year. However, the system also has a limitation. It has to be inferior depth and surrounding environment, mainly from the video, and the human driver must remain attentive. So Tesla should not be described as a fully automation system. Let's compare Tesla and Waymo. Waymo provide higher automation but within a limited operational environment, whereas Tesla provide a lower level of automation but it operates across a larger consumer fleet and uses the human driver as a fallback. So Waymo focus more on controllable boundary automation, while Tesla focus on scalable and rapid improvement. The important lesson is that improving the AI model alone is not enough. The operational environment, sensors, safety system, and human responsibility are also important. Let's talk about the ethics and future. One is accountability. If an autonomous vehicle causes an accident, responsibility can involve the driver, manufacturer, operator, and other supplier. Privacy is another concern because vehicles can collect cabin video and detailed location information. There can also be bias if the training data does not represent a different population, location, or situation equally. The goal should not simply be to add more feature. The goal should be reducing the harm and improving the safety. In conclusion, to conclude, self-driving and safety is not just about having a powerful AI model. It is complete system involving sensors, software, real time computing, cyber security. The comparison between Waymo and Tesla, that there are different approaches to autonomous driver. Waymo uses high autonomous within the controlled environment, where Tesla focus on large scale driver with human supervision. My main takeaway is that AI capability alone does not make a vehicle autonomous. Safety autonomous is a verified system properly. Thank you for listening.